from our worksheet, using calculus, we're going to find the point that is minimum distance away from this coordinate and the curve y equals sine x. Well, let's think about this for a moment, okay? Here is sine x, and pi by 4 1/2 is probably going to be right around that value here. Right around here. And so I'm looking for this distance. Okay, and so to find that distance, and I want that distance to be a minimum. Well, I know on this point here on the curve, that point is simply going to be my x is x and my y is sine x. That's the value of the y curve. This point is just this. Now if I want to find the distance, I can use the distance formula, which is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, if I plug my values in for this, my x, I can go x minus pi by 4 squared plus my y value is sine x minus 1/2 squared. This is d. And I want this to be a minimum. To make it easier for myself, if this is a minimum, I also know if I square both sides, d squared, I know if d is a minimum, and then also d squared is also going to be a minimum. So this particular function will be a lot easier to differentiate than the first one. So let's take a look at this. This one is squared. So I'm now going to take the derivative of this. So to do that, let us go the derivative of d squared dx. I have to do chain rule. So 2 x minus pi by 4 to the power 1 times 1 plus 2 parenthesis sine x minus 1/2 times the inside derivative is simply cosine x. So if I tidy this up a little bit, there's not much to tidy up, but I have 2x minus pi by 2 plus 2 cosine x sine x minus 1/2. And so this is my derivative. If I want to find a minimum, I'm going to set this equal to 0. Okay? Now I'm going to use my technology to do this because setting that equal to 0, that's a nightmare. So let's go to our calculator, and I'm going to type in 2x plus 2 cosine x parenthesis sine x x parenthesis minus 0.5 close the parenthesis. Now that is my derivative. If I graph it, I get that. I'm going to check my window out in just a second here. My window's going from 0 to 2 pi, and so this value here is going to be 0. So let's go and calculate that. Calculate the 0. My left bound, let's make 0. My right bound, let's make 1. And I'm going to guess 0.5. And I get my 0 is simply, let me pull this here, the 0.247. So I know the x value to solve that equation is equal to 0.247 to 3 significant figures. Now I also want to make sure that it's a minimum. So if I consider that I want to go my derivative, so d dx, and this is just d squared, and this is d squared, at 0.247, I know, I can tell from my graph, that it is negative. Negative. And these values here are positive. Decreasing. Increasing. Therefore, a minimum. So, to answer the question, you can find the point that is the minimum distance away from there. Well, here's my x value. If I want to find the actual coordinate point, if x equals 0.247, I want to plug that into my sine function to find the actual coordinate point. The sine of 0.247. Doing that in my calculator. Oh, hold on. Sine 0.247 is 0.244. So I have my coordinate point 2.47, comma 2.244. This point is minimum distance away from pi by 4 1/2. So this is the coordinate point 0.247, comma 244.